In this tutorial, we are going to build a room in ease using several of its drawing tools. This will be a practical hands-on tutorial, so if you'd like to follow along and you don't have ease yet, feel free to download a trial version from AFMG's website. The ease version we'll be using is the ease 5 first edition. The room we are going to build is this auditorium. It is a demo project shipped with ease, and you can typically find it in this folder. To build the room, we'll be using the imported 2D drawings you see here. Of course, we'll be doing this step by step since the beginning, including the importing of these background images. Before we go ahead and start our project, let me briefly show you how to navigate with the mouse and change some presentation settings in these. In order to turn the view or orbit, hold the right mouse button and move with the mouse. To drag or pan, hold the middle mouse button and move the mouse. And to zoom in and out, just use the spinning wheel. This is the convention adopted by ease, but you can also navigate using other conventions, such as the ones adopted in AutoCAD or Rhino, according to this table. Next, you can change the viewing settings for this 3D view under the Presentations ribbon menu. From here, you can change the view from central narrow to central wide, or parallel depending on the type of view you prefer at a given moment. You can change the view direction. You can hide parts of the room if you'd like to. You can change the surface presentation style. And you can turn the visibility of items on and off. These are the settings for this 3D view. We could also have more than one 3D view with its own settings. And different position on the screen or in a separate monitor. Good. I will now click Windows, Default, and this resets my window layout. Now that you know how to navigate, we can start a new project and build our room. File, New. The first thing we'll do to build our auditorium is to load the 2D drawings that we can use as a reference to enter the room geometry. Of course, we shouldn't expect that we'll do that for every model. Each project has its own peculiarities, and we want to think beforehand about which strategy we want to adopt to enter the room so that this test can be done easily and as fast as possible. For this example, we'll use the demo drawings that are also available to you. These drawings are rather simple representations of real-life 2D drawings, but they will serve well our demonstration purpose. This is how we import these reference drawings into ease. Let's click File, Load Drawing, then browse to this folder. You can see that under our project folder, there's a subfolder called Drawings, where we can find these image files. You can see here all the file formats supported. And we want to select floor plan SI so that we see the dimensions in meters. Open. And what we want to do here is to first adjust the scale of the drawing. Click Scale. Find the largest non-dimension of the drawing. In this case, it is this 30 meters line. Then we need to set the start point and end point of our scale line. Next, we inform ease that that distance is 30 meters, as you can see from the drawing. The next step is to position the anchor point in a place that makes sense to us. So in this case, I would like to put it in the front of the stage, here. And then we can position this drawing at the origin. Finally, we need to make sure that our room is correctly oriented. So we need to make sure that the loudspeakers will be pointing in the -y direction. If we put loudspeakers here and here, for instance, and our audience is here, that's indeed the case. They will be pointing towards the -y direction. In ease, the green color indicates the y coordinates axis, the red indicates the x axis, and the blue z. So indeed, the room will be correctly oriented. Next, we import the side view. Here again, we need to adjust the scale. I'll choose this distance. I click to define the start point and then the end point. And I'll let ease know that that's 30 meters again. Next, we position our anchor point. Here is the front of the stage. And so here is my stage, here is the audience. And then I need to rotate this drawing. I can click here in type of drawing, section. And you can see that it's correctly rotated in this case. Next, let us position it correctly. Y coordinate will be 0. And we could position it at x 20, for instance. So our drawings should align. You could also switch to parallel perspective if you'd like to check the alignment of the drawings. And then we can import the front view. File, load drawing, front view. I'll choose this distance to position my scale line. Again, 30 meters. And for the anchor point, I'll just choose the top of the ceiling here. So again, I need to rotate it. In this case, I'll click front and then position it properly. It should be located at x equals 0, y equals 20, and z, you can see here from the drawing that it should be 20 meters. So now our 3 drawings should be correctly positioned and they should align. And indeed they seem to align. Now that we imported the 3 drawings, we can start building our auditorium face by face or wall by wall using different features. This likely won't be the fastest way to build the room, but this will allow me to demonstrate several features to you. To create the room faces, we use the polygon tool. You can find it under the Surfaces ribbon menu, Insert Polygon. And if you hover over its button, you can see all shortcuts associated with this feature. This can be a really good reference. Click the polygon tool and we'll start with this floor face. We'll enter each of its vertices using the control bar you see at the bottom of the screen and absolute coordinates. You can see from the drawing that since my origin is here, this point is located at x equals -10. So just start typing -10 and you can see that focus switched to the control bar. And y in this case is indeed 0 and the same for z. So you can see a little cross with the preview of where the point will be inserted. If I switch focus back to the control bar just by pressing tab, for instance, see that the little cross is now at the position we want to insert the vertex indeed. I press enter to insert my first vertex, and then my next vertex is at x equals 10. You can see an estimate here from the status bar, but you can also infer from the drawing. So type again 10 and press enter. The next vertex is at y plus 10 and also x plus 10. So just change y coordinate in this case because x is already correct in the control bar. Press enter. And then my last point is at exactly x equals minus 10 and y equals 10. And then to close the polygon, I could click the first vertex we entered again, or I could just press C key to close it. And here we have our first phase. Now, in ease, the acoustically active or front side of a phase should always aim towards the room inside. If you hover over a phase, or when it's selected, you see a thick border when you're looking at its front side. When looking at its back side, you see a normal border. If you're not being able to hover the phase very well because of the drawing in the back, you can press Ctrl and then move the mouse wheel to select elements that are behind each other. Notice that our floor face is already correctly oriented by default. That's because floor faces or faces in the Z-plane always aim upwards towards the room inside by default. In addition to that, any new face that we create by snapping to at least 2 vertices of an existing face, such as this one, will also be automatically oriented to match the existing geometry. That is, in this example, the next faces we will create will also inherit the proper orientation. And that is why we recommend that you always start your model by drawing the floor faces. So this is a convention you might want to follow from now on whenever drawing these. Okay, moving on, we'll create the next floor face, this face. Click to activate the polygon tool, and then we'll snap to this existing vertex and then click. Then do the same for the second vertex. And then this time we'll use relative coordinates to enter the next 2 vertices. So for that, I'll hover over the last vertex I entered and press R to set a reference point in this location and switch the control bar to relative coordinates mode. Now we can enter the distance from this point to the next vertex. We can see that this vertex is at 10 meters from the origin, while this vertex is at 15 meters from the origin. So we have a difference of 5 meters in the X direction, and then 20 meters in the minus Y direction. We can also see from the side view that this point is located 5 meters from the floor. So for Z, I'll enter 5. Then I'll press enter. The next point will be approximately at this location, but first notice that the first 3 vertices define the plane of this face. And now every new vertex we insert must be part of this plane. That's because in these, all faces must be planar. So to insert the 4th point, you can see that's located 30 meters in the minus X direction from this vertex. So here again I can press R to set my reference point to where the little cross is, and then type minus 30 and press enter. And then we can close the face by clicking this vertex. If we hover again over the polygon tool, we can see that we can press X, Y, or Z to set a base point or a reference point and activate an axis constraint. So with the polygon tool active, we could, for instance, snap to this point and press Z to activate the axis constraint in the Z direction. And here we can type directly the distance in the Z direction that we would like to have. Or we could use the mouse to define the height by, for instance, obtaining it from other points. So if I snap to this point, you can see in the status text here on the bottom that I get a height of 5 meters. The same for this point. Here, Z would be 0. So I could just snap to other points and obtain the height from them with the Z restriction active. Or we could just project over the drawings that we imported and get the Z coordinate from them. If I press Z again, it will deactivate the mode. and I could press X and Y to restrict the entry in those directions. So I will enter -10, for example. I could now immediately press Y and enter 10, then Z, 20 for instance. Then I'll go back to Y to activate the axis constraint in the Y direction. And now instead of using the control bar, I'll use the mouse to obtain the Y coordinate of these vertex. And then I'll just click. And notice that at the moment my reference point is located here. As soon as I press X, Y, or Z to activate an axis constraint, my new reference point is defined. So just press Z and I'll enter -5. Then in the Y direction, 5. In the Z direction, -5. In the Y direction, -5. And then I'll just close this face. This was just an example on how we could use the axis constraints to create a face. But we don't need this face, so I'll press Ctrl Z. Now we will create this sidewall using this axis constraint. So let's activate the polygon tool again. Hover over this vertex. I'll click to already insert my first point here. And then I'll press Z to activate the Z axis constraint. And to create my next vertex, I'll just hover over the drawing to get the height that I need. And click. From here, we could, for instance, activate the Y axis constraint. So I'll hover over the last vertex we inserted and press Y. This will set a new reference point in the position where we inserted the last vertex. And with the Y restriction active, you can see that X and Z are fixed and only Y varies. We can obtain the Y coordinate from this vertex. Next, we just click to close. And again, because this face is connecting to a face that is already properly oriented, it already has the correct orientation. So its front side is aiming towards the room inside. To create the next sidewall, we can again use the Z axis constraint. So let's activate our polygon tool. This time I'll press twice, and this will activate the keep mode, which allows me to enter several faces without having the polygon tool being automatically deactivated. We'll hover over this point, activate the Z axis constraint. Then again, I'll get the height from my drawing. And then we can just click the existing vertices to close this face. After we create a face, we can see the coordinates of all vertices from the properties window of the face here on the left-hand side. If you hover over this list, you can see that the corresponding vertex is highlighted in the 3D view. You can delete any vertex by pressing the small trash can button. And if you'd like to, you can correct the coordinates of a vertex using the Move Vertex tool. For instance, we could correct the height of this vertex, which should actually be exactly 15 meters. So to do this, we activate the Move Vertex tool, and then we click the vertex we want to change. And then we can define its coordinates just as we would when entering a new vertex. We can use the mouse directly, we can use the control bar, axis restrictions, and so on. In this case, I'll hover over this vertex, press Z to activate the axis restriction in the Z direction, and then I'll enter 10 meters, which should be the correct distance. Just be aware that the vertex you are editing should continue to be in the plane of this face, so ease will restrict you in case you would like to move the vertex away from the plane. Moving on, to create the left side wall, we can duplicate this existing wall and then position it properly. So that's what we are gonna do. Click Tools, Duplicate, and then hover over the face you want to duplicate. You can see that there is a red bubble that indicates what is the anchor point you would like to choose. I'm gonna choose this point over here and then click to activate the mode. And immediately you can see a preview of the duplicated face. So you can specify its location with the mouse by snapping to existing vertices. You could use the control bar and enter a distance relative to our reference point. You can see that right now our reference point is located here, So I could enter minus 20 meters directly. But of course, we could also change the position of our reference point if it makes it easier for us to type the coordinates. So in our case, I'll just use the mouse and snap to the point I want to insert my face. But before we go ahead and do that, just notice that from the control bar, we could also change the number of duplicates. Right now it's set to 1. We could change, let's say, to 4. And you can see a preview of all 4 here. But that's not what we need right now, so I should switch back to 1. And then finally enter the duplicated face. Let me deactivate the duplicate mode by pressing ESC. Notice also, if you hover over this face, you see that its front side, it's pointing towards the room outside. That's because the duplicated face just inherited the orientation from the source face. So it's pointing to the room outside. But we can easily fix that with the invert face tool. So activate the invert face and then just click the face I want to invert. Now they should be correctly oriented. We can see the front side of this one and we can see the back side of this one, which is correct. Now let's take a quick step back and activate the duplicate tool once again and see what would happen if we created a duplicated face in the same position of the source face. Of course, this would be a mistake, and Ease is highlighting this mistake with this orange color. Ease will do that to raise a warning that there are 2 faces here with approximately the same shape, very close to each other. And this is not allowed. This is one of the conventions you should be careful to follow in Ease. You should not have stacked faces. But Ease lets you know immediately once that happens. If you switch to the presentation ribbon menu, you can see under geometry analysis section that stacked faces is active. If you deactivate this feature, Ease will not look for these mistakes anymore. So it's a good idea to keep it always active and be able to see as soon as a mistake like this occurs so that you can fix it immediately. So how do we fix this? Obviously, you can just remove one of the faces. Also under geometry analysis, you see the whole outlines feature. This mode will highlight any missing faces and inverted faces in our model. You can see that at this moment it is highlighting some parts of our model, and by visual inspection we can just see that there are missing faces, which is expected since we're still building the room. And in case, let's say, this face is inverted, you see that all of its edges are now highlighted in red. Now if we invert it again, you see that these edges are not highlighted anymore, only the other 2 edges, which are related to the other problem of missing faces. So we can turn the whole outlines display on at any time to inspect our model and see if there are any holes, as we call it in Ease. And because this feature constantly checks our model with every change we make, we can in fact just even leave it on while we finish drawing the room and use it as a quick visual guide of which parts of the room are still missing. So let's do that in this example and just leave it active, and we can move on to create the remaining walls. Click again the polygon button and let us insert this back wall now. We'll start by clicking this vertex, and then here we use a different feature. We'll press Shift Z, and this will activate a Z plane restriction, which means that Z coordinate is fixed, as you can see here from the status text, and X and Y are allowed to vary. So now we know we have the correct height from this vertex, and we need to obtain X and Y, for instance, from this vertex. So Shift plus Z activates the Z plane restriction. Z is fixed, X, Y are allowed to vary, and it always uses the Z coordinate from the last vertex you entered. It does not use, for instance, the mouse position or the cursor position, which is different from the Z axis restriction, which locks X and Y coordinates and allows you to move freely in the Z direction. So now we can just close this face. Also, the next sidewall we can just create by clicking these existing vertices. Next, to create this front face, we use one more resource of the polygon tool, which is activated by pressing the shortcut key S. As a simple example, I will hover over the midpoint of this edge. First, let me quickly switch to absolute coordinates again, and then press S shortcut key to switch focus to the control bar, while copying the coordinates of the cursor position to the control bar. So they were x equals 0 and y equals 10. Now I have the exact x and y that I need, and then I can just Alt Z to 20 meters and press enter to create that top vertex. Then again, we can click the existing vertices and close this wall. Good, with the front face inserted, now there are only 3 faces remaining to be inserted in our model. This triangular back face, and then the 2 ceiling faces. We can see how this back face will look here, and to create this face we have actually several alternatives by now. I will choose to hover over this vertex, and then press Y to activate the y-axis restriction, and then obtain the y-coordinate from the midpoint of this edge. So if I click, it will add the point on the top, and the rest is easy. We can just close the face. Finally, we can enter the 2 last faces. Remember that faces in these must be planar, therefore we need to enter these 2 faces here. In fact, if we try to create only 1 face for the ceiling, you can see that ease will not allow you to do that. It's always projecting over the plane that is defined by the first 3 points you entered when you start creating this face. So let's undo that and enter 1 face first. And then the last face. If you make any mistakes, as I did now, you can press U key to undo the insertion of the last vertex. And we are now done entering our room geometry. Pressing ESC to leave the polygon mode. And you can see that the whole outlines display is still active, but nothing's being highlighted in our model. We can also confirm that the room is properly entered by looking at the Acoustic Parameters view, Volume tile. More specifically, this vertical green stripe here. When its status is green, you can read from this tooltip that it indicates room closed. To ease, a closed room is either a room that is completely closed or closed enough, closed to a degree that any holes will not affect the calculation results significantly. This means that ease tolerates small gaps in the room. As a matter of fact, if we go back to our model and take a very close look at this connection between our ceiling and these 2 side walls, you can see that there's a tiny opening here, and that's completely acceptable for ease. Adjacent faces do not need to connect precisely, and small gaps like this one can be neglected. Of course, if the gap is big enough, ease will indicate that with either a yellow or a red status color here. And as we have already seen, it will also highlight the gap in the 3D view if the whole outlines mode is active. If we go back to our model, we can test that by, for instance, slightly moving these vertex. Let me show you that. I'll click this face to select it, go to the surface ribbon, move vertex, and then I'll click this vertex and move it a little. We can see that the gap is outlined mostly in red. If the gap is between roughly 10 centimeters and 40 centimeters, the edges are highlighted in yellow. And if the gap is larger than that, obviously they are highlighted in red. And in the volume tile, we see now a yellow stripe. If we hover over it, this tooltip appears and it reads, room approximately closed. A small number of faces are missing or have the wrong orientation. Calculation results are only approximately valid. Please make sure that the room is closed and all faces have the right orientation. Use the geometry analysis tools that we saw to find effective faces and holes. Insert missing faces and invert faces with the wrong orientation. Note that with this status, Ease will still let you run the calculations. Right now, this is just a warning. We can do one more test. Let's go back to our model. And now let's completely remove this face. You can see that the whole outlines display is showing us that there is a problem here. And if we go back to the volume tile, the status color is now red. And the tooltip reads, room open. A large number of faces are missing or have the wrong orientation. Calculation results will not be reliable. This means that calculations that depend on the correct room geometry entry, such as the volume calculation or the calculation of the statistical reverberation time, will not be reliable. So let's close our room properly by inserting the sidewall back. I'll press Ctrl Z for that. And if we look at our volume status again, we can see that green color, which indicates room closed, and our volume calculation should be correct. You have now seen several features you can use to enter the room geometry while making sure no drawing mistakes occur that could cause the room to be open, unless performing simulations in an open space is actually your intention. To conclude, if we go back to our Acoustic Parameters view and take a look at the Reverberation Time tile, you will notice a red status for it. By zooming in at this tile, we will also notice large and unrealistic RT values. That's because we haven't assigned any materials to the faces in our room. In the next tutorial, we'll see how to assign these materials and view the calculated reverberation time. We hope this tutorial was helpful to allow you to get started with ease. If you have any questions, please get in touch.